We're going to do another problem from Let's Review Physics, the Barron's Review, on page 31. Question number 29 says, an object is allowed to fall freely from near the surface of a planet. The object falls 54 meters in the first 3 seconds after it's released. The acceleration due to gravity on the planet is... Okay, so we see this is not Earth. So it's not going to be our gravitational constant negative 9.81. That's only true for Earth. Other planets have different accelerations. So if we go to our paper, we can write some of our givens. So the first thing when we reread our problem, object is falling on a different planet. Object falls 54 meters. So our displacement is negative 54 meters. Why is that negative? Well, displacement is a distance, that's 54 meters, but also a direction. Since things are falling down, this has moved from higher to lower, and it's a negative displacement. Down is negative. And we have a time. This happened in 3 seconds. Okay? If it was dropped from stationary, the object was released. So it tells us it was let go, it was released. It was not thrown. If it was thrown up or thrown down, we wouldn't have an initial velocity of 0, but it says it was just released or dropped. So our initial velocity is 0 meters per second. Okay, so you got to read kind of closely. Even though there's no 0 in here, they're letting us know it was released or dropped. Okay, now they're asking us what is the acceleration. So we have a distance, a time, an initial velocity, and we're looking for an acceleration. So if we go to our reference table and look at our formulas in the mechanics section, we have 3 choices to choose from, and we see that we have initial velocity, distance, and time. So this first equation is not going to be a good choice because it's asking us for the final. We would need the final to be able to find the acceleration, and we don't have it right now. And the same is true here. This also includes the final velocity, which we don't have yet. So we're going to go with this second equation, I'm saying second, but the second of those 3, which is actually the 4th formula on the back of the reference table, that distance formula. So if we copy that down, distance equals the initial t plus 1/2 at squared. And our distance, distance or displacement in this case, because we know it's moved down, we're going to use that negative 54 meters. It's gone downward. We have a v initial of 0 meters per second, a time of 3 seconds, 1/2. We're looking for our acceleration. Then we have 3 seconds squared. We can do a little bit of math. We have negative 54 equals 0 times 3, that's just 0. Then we have 1/2 a, and 3 squared is 9. So negative 54 equals 4.5. So we did half of 9, 4.5 times a. Divide both sides by 4.5. Okay. And you can use your calculator for this. I'll do it quickly here. 54 divided by 4.5. We have 12. Negative 12, and this is acceleration, meters per second squared. So let's check our choices, and choice 2 is negative 12 meters per second squared.